Welcome to the final lesson in the Stoichometry unit. Please get out your notes, something to write with, a calculator, and your periodic table. When we calculate amount to product in a stoichiometry problem, the calculated answer we get is called the theoretical yield. This is because it is the amount we would get theoretically if our experiment went perfectly and we had no experimental errors or limitations in our procedure. However, in the real world, we do not often get it perfect. The amount to product we get when we do the reaction in lab is called experimental yield. We can compare our experimental yield with the theoretical yield to see how well we did. To do this, we use the formula below to get a percent yield, or the percentage of the theoretical yield that we obtained in lab. The closer we get to 100%, the better we did. This means less error. The formula is percent yield is equal to experimental divided by theoretical yield multiplied by 100. Remember that the answer is in percent. Here's a sample problem. The following reaction is performed by a student. She starts with 0.25 grams of magnesium and excess hydrochloric acid, and she obtains 0.90 grams of magnesium chloride product. That is her experimental yield, because she got it from performing an experiment. What is her percent yield of magnesium chloride? Well, first, we must calculate the theoretical yield of magnesium chloride with stoichiometry. Even though the question is worded differently, the stoichiometry calculation is no different than anything that we have done up until this point. We start solving by writing down the given, 0.25 grams of magnesium. Since the given is not in moles, we must convert it to moles according to step 1. So I must get rid of grams of magnesium and go to moles of magnesium. Since this is not moles to moles ratio, 1 goes in front of mole, like always. 24.305 is the molar mass of magnesium, which goes in front of grams. In moles to moles ratio, which is always a required step, I get rid of moles of magnesium by placing it on the bottom, and on top I go to moles of magnesium chloride to answer the question. The numbers come from their coefficients in the balanced equation, which are both 1s in this case. Even though it is not explicitly stated in this question, when asked for theoretical yield, it is really asking for grams of the product, which in this case is magnesium chloride. So we have to do step 3. Here I get rid of moles of magnesium chloride by placing it on the bottom, and get to grams of magnesium chloride on top. 1 goes in front of moles because we only use coefficients in step 2, and 95.211 is the molar mass of magnesium chloride, which goes in front of grams. The final answer is 0.98 grams of magnesium chloride, which has 2 sig figs just like the given. This is how much magnesium chloride should be theoretically produced from using 0.25 grams of magnesium as the limiting reactant. Now let's go back to the main question. What is the percent yield of magnesium chloride? The experimental yield was given to us in the problem, which was 0.90 grams of magnesium chloride. The theoretical yield we just calculated, which was 0.98 grams. Plugging these values into the formula, where percent yield is equal to experiment over theoretical multiplied by 100, we have 0.90 divided by 0.98 times 100, and the final answer is 92%, which is very good. Remember that it is very hard to get 100% yield because our experiments aren't perfect. On the other hand, your answer should never be higher than 100% because theoretical is already the maximum amount of product you can produce, and you can't produce more than the maximum. Here's the case of another student who obtained 0.74 grams of magnesium chloride product, starting with the same 0.25 grams of magnesium. What is his percent yield of magnesium chloride? Since he is starting with the same amount of magnesium, his theoretical yield is exactly the same as the other student. which was calculated to be 0.98 grams of magnesium chloride produced. However, his percent yield is different because he obtained a different amount of experimental yield during lab. Plugging these values into the same formula, where experimental yield divided by theoretical multiplied by 100, his experimental is 0.74 grams, and he has the same theoretical yield as the other student, which is 0.98 grams. 0.74 divided by 0.98 multiplied by 100, his percent yield is 76%, which means his lab result is not as good. The first student who got 92% obtained a higher percent yield. Therefore, her experiment has less error. This student, who got 76% yield, may have more error in his labs than the other student. The closer the percent yield is to 100%, the better. But remember, you can never go above 100%. And that is it for today's lesson. Please do the corresponding page in your stoichiometry packet.